Hello, I'm Brandon Doyle, and this is my first assignment to Introductory into Ammunition and Basic Ballistics. Today is June 8th, 2025. Let's get started. My current superficial understanding of the four steps of ballistics are: internal is the theory of the projectile and cartridge, transitional is the study of the projectile once it has exited and cleared the muzzle, external is the study of the projectile in flight, and terminal is the theory behind the projectiles impacting its target. There were quite a few things that interest me while researching this video, like the amount of gun websites that I found while researching. Google likes to take a lot from them, especially Wikipedia. That's why you gotta really look into the websites that it pulls from, because we all know how Wikipedia can be so unreliable. But gun websites like Grizzly Cartridges LLC, Hilux Optics, and Rogue Concepts were some of them that Google's AI pulled from, and I'm very excited to look into them more. Now, for the variables that can affect the flight of a bullet and its performance is the wind resistance. That can stop that can slow down the bullet's distance it travels. The wind can blow the projectile off course, as well as the bullet's weight and shape can affect its performance and distance, as well as the factors like temperature, altitude, humidity that can cause drag and the bullet to drop sooner. I was very shocked when I found out temperature could affect a bullet's performance. That was quite interesting to say the least. As for sectional density, I tried my best to be able to shorten this to where somebody that is unaware of what sectional density is can understand this. Sectional density is essentially the amount of weight compared to the space the bullet takes up. The greater the weight compared to the size, the greater the penetration. And for the question I would like to answer for my assignment is number 1. Is it possible to overstabilize a projectile, and what happens if the projectile spins too fast? That thought did not occur to me until this question was asked. I didn't think it was possible until I thought about the possibility of friction from the wind, and the amount of force the object would feel being forced into several different directions as it spins. It would be quite possible to increase the temperature of it due to the friction, and possible enough for it to melt enough for the lead to be more malleable than it already is. But with modern rounds jacketed, I had to search even harder. But I did find a couple of answers, not changing the fact that it would cause it to go off course with the spinning, but the use of whether or not it was stabilized or, whether or not overstabilized was the proper word, or overspin. Luca.com says this: overstabilizing projectiles does not follow exactly the trajectory of the curved flight path, but flies slightly nosed up. This increases air drag and shortens the flight range. While Google's AI popped up with this answer, overstabilize is sometimes used. A bullet cannot be genuinely overstabilized in the sense of being too stable. The proper term of the phenomenon is overspun or overspin, which occurs when the bullet spins so rapid that the gyroscopic forces are excessive and it can break apart and lose accuracy, according to a video produced by SDK Weber. And in conclusion, I found out overstabilizing is incorrect. The better term that I would use would be overspin, because you're either able to stabilize the bullet or it's not stabilized. But it can overspin, causing a change in the flight path and fall apart. So that's it for now. Thank you for listening, and have a great day.